Hi guys, alright, so we are doing now day 3. We ended on question 5 from day 2, so we're going to pick up on question 6, and it says to find the point on the curve y equals square root of x that is nearest to the point 4, 0, okay? So let's just do a nice little sketch here. And 4, 0, I'm just going to plot that guy first. And now I'm going to let's just do a sketch of the actual curve. So if I plug in a 1 into the square root of 1, it's a height of 1. If I plug in perfect square of 4, it's a height of 2. If I plug in 9, so that's 4, 5, 6, 7, 8, 9, it's a height of 3. And let's just connect those with a nice smooth curve. Alright, so I'm trying to figure out, guys, some point that is on this curve that has the closest distance to the point 4, 0. Alright, so we're trying to find distance, so we are going to use the distance formula. So distance equals the square root x sub 2 minus x sub 1, square it, plus y sub 2 minus y sub 1. Okay, so we are given a point. We have 4 and 0. Great. And the next question is, well, you need a second point. You are always given a point. We can find a million points on this curve. For every x value, I can plug it into the equation and it's going to spit out the output, right? The y value. So technically, the other point we're going to be using, and it's always for every x value, it's going to be the equation as the y, the output. So let's plug in. I'm going to make some room here. Get this guy smaller. That failed. Alright, it's being stubborn. It wants to stay like that. Okay, so let's plug in. Distance equals the square root. I'm going to go x minus 4 squared plus square root of x minus 0 squared. Let's clean this up a little bit. Let's expand x minus 4 squared, so that's x squared minus 8x plus 16. So that is just me expanding this part. And then we have a plus sign. And then if I expanded square root of x minus 0 squared, that just gives me an x. Let's just clean it up. Combine some terms still here. X squared minus 7x now plus 16. Alright, you are then going to be required to plug this into your calculator, okay? So this is what we're going to graph. Give you some time, plug that guy in. Make sure you are doing this, right? Okay, so the instructions while you're typing this into your calculator were to find the nearest point. aka this should be the minimum, right? So I'm going to find the minimum point. So once you graph it, let's hit our minimum, second trace number 3, the left bound, the right bound, and I get this point of 3.5, and then there's 1.93 and goes on. Alright guys, so I'm going to write this out. The coordinate that we got was a 3.5, and I'm going to go hundredths, so 1.94. You plugged in the distance formula. That was in your y equals. That means this is not the y coordinate. This is the distance. The x is the x-coordinate, but the y is the distance. That's what you graphed, okay? So then your last step then is to figure out what is the y. So you need to plug in your x-coordinate. Our point is x comma square root of x. So now I'm going to plug in my x, which is 3.5, square root of 3.5, which is going to give me now approximately, I got 1.87. So 3.5, 1.87. Make sure you remember to plug in that x value, and you understand that that y value that's given from the minimum is the distance, okay? So our final answer then is this coordinate. Okay, let's go to 7. An indoor physical fitness room consists of a rectangular region with a semicircle on each end. The perimeter of the room is to be 200 meters single lane running track. Approximate the dimensions that will produce a rectangle of maximum area. So step 1, I actually kind of took this apart so you guys see your different steps, is determine the radius in terms of y. Okay, so I'm going to go to my radius. It is already represented in y, so that's pretty sweet. So we know that the diameter is the entire thing, right? All the way across is diameter, that's y, so that means our radius is half of our diameter, so half of y, or y over 2, right? Those are equivalent. Step 2, determine the distance in terms of y, so that means I only want y's in this equation, around the inside edge of the two semicircular parts of the track. Okay, so let's highlight this. Step 2. The semicircles, well, there's 2 of them, so technically my 2 halves are going to be, you have 1 whole then circle. And I know my distance around is the circumference, which is 2 pi r, but I don't want r's because I said I want it in terms of y. So I need to replace the r, so that is why we did step 1, where you told me that r is actually equivalent to y over 2. Clean this up a little bit. That means our circumference is equal to, the 2's are going to cancel, because technically you're going to get 2 pi y over 2, cancel, cancel. Circumference equals pi over y, or pi times y. And that's our final answer. Make sure you put a box or a highlight or something so we know this is your final answer. Make sure to keep that work organized, guys. Step 3, write the equation of the distance of 1 lap around the track. So I need to go completely around now. So we have done actually the yellow part. We just have to add the straight running track, so the blue part now. So going around, I know that it's going to be about my perimeter. So I have 2 circles, or just 1 hole. I'm going to write it as 1 hole. 1 whole circle plus 2 of the x's, right? The straight paths. So now I'm just going to plug in from step 2, 1 whole circle is equivalent to pi y plus 2 x's. And that's it. It didn't say specifically in terms of or anything, right? So I just wanted to know the distance around 1 full lap. Part 4 is asking, write the area of the rectangular region as a function of x. Okay, that means I can only have x variables. So area, I'm just going to write the first general part of just the rectangular, it said. So it looks like it's the blue times the diameter, right? The pink, which is a y. So I need to get rid of the y. I just want to have x's. So the issue is here. Well, if we go back to the word problem, it said that the perimeter of the room is to be 200 meters single lane running track. So that means that's the perimeter. And in the previous step, we solved for perimeter. We said that it was equivalent to pi times y plus 2x. So that's 200. Our goal then is to solve this guy for y. So 200 minus 2x equals pi y. Divide both sides by pi. And we got what y is equivalent to, right? So I'm going to take this new y value, which only has x inside of it, and I'm going to plug it in to the area. So technically, that guy goes away, and I'm plugging in the new y in its place. So this is a function as a what in terms of x. So that is exactly what we wanted. And step 5 says use your calculator to graph the area of the function from part D. Okay, so I want you to exactly graph this guy as you see it. Make sure, I'm not going to graph it, so I want you guys to practice. When you plug it in, be careful, I'm writing down how you should plug it in with your parentheses, because when you divide by pi, you don't want it just to divide by the 2x, you want to make sure it's the entire numerator. Okay. You might have to play with your window. In my written notes, I did show you a window that I use to see it. If you don't like to play with the window, hit zoom 0, zoom fit, and then zoom out, and you should get into where the max is, okay? You should get about like 49.999999, so I'm going to round that to 50. And then I'm going to get 1,591 point, I'm going to round this to the 100th, so 55. Just like the previous problem, guys. This doesn't mean these are my dimensions, my x and my y. Okay? This guy right here represents the max area. Just like the other one represented the distance, the y value, so this is the max area. I want to know what are the dimensions to produce. Okay, so I know I'm going to take the 50, but I need to know what is the other dimension that goes with it. Well, you have an equation that says y. On step 4, we had that equation of y equals 200 minus 2x, which is 50, all over pi. Plug this guy in. I got about 31.83. So my dimensions then are going to be a 50 meters by 31.83 meters. That's my final answer. Okay. So these steps, I broke them apart, kind of showing how like the previous one usually will help you out with the following one. So it's a good idea to get in the habit of looking at these, okay? All right. Takes us into question 8. A rancher has 200 feet of fencing to enclose 2 adjacent rectangular corrals. Okay. Write the area A of the corral as a function of x. All right, let's go thinking back to Algebra 1 when you just had to do perimeter of a rectangle, right? And this was a common mistake back then. You would have a rectangle. I would tell you that the length is, or whatever, 5 and 6, And people would just do 5 plus 6 gives me 11. Great. Well, that's wrong, right? Because a rectangle has has 4 sides. Okay. Now let's challenge this up a little bit. Use that concept. Label all of your sides. Don't get fooled by me. Okay? So x and x and x, right? Y. Do not forget this middle y. If you have a highlighter, square it, put a note. That guy gets forgotten a lot. Okay? So we're doing fencing. Every part matters here. So let's write the area of this as a function of x. That means I only want x terms inside of this. So I'm going to go, step 1 is the area. So area equals, if I go with the green side, that's in terms of x's already. So that's a 2x, right? Times the blue side, which is a y, and that's where my issue is happening. I got to get rid of that y. So I have to have some type of equation in here that I can manipulate it to a y. So I'm going to look at my given information. My given information says there's 200 of fencing. That's perimeter. So here's my side work. I have 200 fencing, which equals my entire perimeter. So that's 3 lengths plus 4 widths, 4 x's. Now I'm just going to replace, I have 3 y's plus 4 x's, and our goal is just to solve for y. So let's inverse operation, subtract the 4x, inverse operation, divide both sides by 3. I don't know if it's just you or just me, but I got to get that y on the left side, or it's going to make me go bonkers. So we have it now as a y equals, I'm going to take this new y in terms of x's and plug it into the area equation into the y spot. So my area equals 2x times 200 minus 4x over 3. And I'm going to close that guy up. So this is the area of the corral as a function of x. It didn't ask me to distribute or anything. I am totally fine with you leaving it like that. Okay? Part B is asking us, use your calculator to approximate the dimensions that will produce the maximum enclosed area. Okay, so what you should do now is to graph this guy. So part B, I'm going to let you have time now. Into y1, you should be graphing this guy. So 2x times, and then again, be careful with your parentheses. You want your entire denominator or numerator to get divided by the 3. So double parentheses, okay? Pause me here until you get your max, because we're going to go straight into the answer. Okay. Your answer, or your maximum, right? You should have gotten a coordinate that is 25, and then I got approximately 1666.67. I'm rounding up, okay? I didn't ask what is the maximum area. If I did, that's the y value here. I want to know the dimensions. So I want to know my length and my width, right? Okay, my length is the green highlighted, which is the 2 x's. So I take my x value, plug it in, and I get that 50. Okay, and I'm going to put my units for word problems, so 50 feet. My width is the equation that we manipulated for y, right? So I have 200 minus 4 times the x, which is 25, all over 3, which approximately I get it as 33.3 repeating feet. And those are my answers. I'm going to put that box around so I know this is the end of my thinking process. Okay, hint. Biggest mistake that happens here, guys. I'm trying to help you out. Common mistakes. 1, people forget that there's 3 y's like I told you earlier, right? Make sure you label all 3 y's, okay? Second mistake, they use the y coordinate of the vertex as the width, aka that 1666, right? They use that. Remember, when I ask you for coordinates, you are taking the x value from the vertex and plugging it back into the equation, okay? All right, good work here, okay? So that takes us into the last one, example 9. The strength of a wooden beam of width x and depth y is given by the formula S equals. A beam is to be cut from a log of diameter 10 inches as shown below. Part A, express the strength of the beam in terms of x. Okay, there's a lot that was given out right now, so I'm going to, like always, label my diagram. That should always be your first step, okay? Break it apart. So I'm going to say my y value is my length. The bottom, I'm going to say that's my width, my x. And then it said that the diameter going across was 10. I believe it said inches. Let's double check. Yep. Okay. So I labeled that. So express the strength of the beam in terms of x. So I only want x in some type of equation. What can I do here then? What type of shape do you see inside of that rectangle? Hopefully you can notice it with me highlighting it. It is a triangle, specifically a right triangle. What should you do? What type of theorem should you use with a right triangle? You should be shouting this out. Pythagorean theorem. So if I have x squared plus y squared, it should equal 10 squared. Let's get this into a y equals. So y squared equals 100 minus x squared. Take the square root on both sides. Remember, you take the square root, you are going to have a plus or minus, right? Now ask yourself, in word problems, you might have to drop one of them down and ask, does it actually make sense? In this one, we only want the positive one because we're talking about a length, right? Okay, so now what do? We were given an equation. The given equation was the S equation. S equals 13.8 xy squared. That's the strength equation. But I said in terms of x. So let's take away the y and plug in what we just solved. So square root of 100 minus x squared. So I just manipulated it, took away the y, plugged in the new y in terms of x. I'm going to clean this up a little bit. So S equals 13.8x. Square root, squared, cancel each other out, guys. So 100 minus x squared. Which I can even clean up more. Negative 13.8x cubed. I'm just distributing here. 1380x. Okay, so we took the strength equation, we manipulated it so it's just in terms of x. What is the domain of this function? So if you graph this, it's probably a good idea to see, but the domain is talking about your x values, right? It has to be a positive values that are in quadrant 1 only. Like, we're talking about distance, length of beams and stuff, so it needs to be positive. It cannot be 0, or this beam is going to completely fall over. And it cannot be more than 10, because that is the hypotenuse, and we know that the hypotenuse has to be the longest side, and that's why we're putting it in parentheses, because we are not including that 10. Okay, so this is the x in width, which cannot be greater than the hypotenuse. Okay, so those are my x values. What width will make the beam the strongest? Okay, so I need you then, hopefully you still have it in your calculator, and you graphed it, and you found the max. Okay, so I'm going to copy what I found as my max, and I have about, and I'm going to round to the nearest hundredth, so 5.7, and then I got 5,311.62. All right. If you didn't do this, you should be pausing me and making sure you graph this. You don't want to be doing this for the first time on a test. So the first number is representing the width. And remember, the second one doesn't talk about the length or the other point or the y value or anything like that. It always talks about what, like, the original problem was asking. Like, what did you graph? Well, we graphed the strength equation. So the output is the strength. So in this example, I actually asked for the width, right? I didn't ask for the length, I asked for the width. So this one was given. So the width is approximately 5.77 units, guys. Word problems, units. Put a box around your final answer. All right. That is the end of day 3, guys. Okay, so then we have day 4, which is going to be like a nice review, putting everything together. Make sure you annotate these notes, figure out what do I have still a question over to ask Miss Kraybeck, okay? Keep up the great work, keep advocating for yourself, making sure you're on track, okay? All right, I'll see you tomorrow.